This is the solution to test number 4, and I think it's critical that you understand the concepts because you're going to be using this for the rest of the year, not just this semester, but the rest of the year. So here we go. Number 1, the indefinite integral of 3x to the 4th plus 5x minus 7 dx. Notice the parentheses around the whole thing, so I know it's multiplied by dx. So you guys tried to make this harder by treating it as u substitution. And u substitution is only required if the original integral can't be integrated just using the integrals in the table or the formulas that we have. So since this is just a polynomial, we just do polynomial integration. So you add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent. The integral of -7 is -7 dx, -7x, and at this point we add the arbitrary constant c. So anytime you integrate, the next step should have the arbitrary constant. So that's it. That was all there was to that one. Okay, number 2, this indefinite integral. So when you have an integral that you can't just use polynomial integration with, then you have to use u substitution. So I think you guys did a better job at this. So we let the argument of the exponential part be u, and then we take the derivative. So the derivative of 2 is 0, and the derivative of -4x squared is -8x dx. So don't forget the dx in this part. Now we look back at the original integral, and what we can do is we can pull the constant out, and what that leaves is x dx. So that's what we want here. We want x dx, so we're going to divide both sides by -8. So you get x dx is -du divided by 8. So now the original equation, 3 comes out, you have x dx, which is going to be -du over 8 times this, which is u raised to the 4th power. We can bring out the -1/8, so you get -3/8 the integral of u to the 4th. At this point we have a polynomial which we can integrate using the formulas. So we add 1 to the exponent, divide by the new exponent. We add our arbitrary constant c at this point. We don't wait till the end, we do it when we integrate. So if we clean up the constant part, you're going to have 5 times 8, which is 40. So you get -3 over 40, u to the 5th plus c, and then we stick u back in. So you'll have -3 over 40 times x 2, or pardon me, 2 minus 4x squared raised to the 5th power plus c. Okay, number 3. So similar kind of thing, except you've got a square root involved and it's in the denominator. Again, we can't just do a simple polynomial integration. So because we have something in the argument of the square root, we can choose that as u, like that. Okay, du is equal to -9x squared dx. And you can see I have x squared dx here, and I have x squared dx there. So again, I'm going to pull the 4 out. This part, 1 over the square root of that whole thing becomes 1 over the square root of u, and then I have negative. Okay, so what I'm going to do here is I'm going to solve for x squared dx, which is negative du divided by 9, so that goes here, du divided by 9. Now, notice I put the parentheses here. I didn't point it out in the previous problem, but if you have a negative sign, you've got to put parentheses around it. If you didn't have a negative sign, you wouldn't necessarily need the parentheses, but I need the parentheses to clarify that this is not subtraction, that it's the negative of that quantity. Okay, so we factor out the negative, the 4 and the 9, and we rewrite this as to the 1/2 power and move it to the numerator. So it becomes u to the minus 1/2. It's 1 over u to the half, which is u to the minus 1/2 power. Now we integrate it, so you add 1 to the exponent, divide by the new exponent, plus add your arbitrary constant c at that point. And if you take the reciprocal of this, you multiply, instead of divide by half, you multiply by 2, so you get negative 8/9 u to the 1/2 power. So u is 4 minus 3x cubed to the 1/2 power. We said that anytime you have something to the half power, you rewrite it back as a square root. Okay, so that's the answer. Number 4, we have the integral of the cosine of negative 3x. So yes, the integral of the cosine is the sine, but we don't just have x. The formula in the book says the integral of the cosine of probably u du. Well, u is not x, so it's not just the sine of u plus c. It's going to, we have to use u substitution. So u is the argument of the trig function. So when you take the derivative, you get negative 3 dx. You can see what we need to substitute is for dx. So you get dx equals du divided by 3, negative du divided by 3. So when you make those substitutions into here, you get the cosine of u times dx, which is negative du divided by 3. And so you can bring the negative 1/3 out, and then the integral of the cosine of u is the sine of u. You add your arbitrary constant c at that point, and then you substitute u back in, so you get negative 1/3 the sine of negative 3x plus c. So that's your answer on that one. Okay, moving on to number 5. So this is where you're given a differential equation, dy dx equals 3 plus 2x plus 3x squared with the initial condition of y of 1 equals 4. So you multiply both sides by dx, and some of you guys left out steps here, but I don't want you to leave out steps. So from that, now we can integrate both sides. Okay, so now we integrate. The integral of dy is y. And then here you integrate. Most people did the integration correctly. And we add our arbitrary constant c after we integrate. And then you can simplify it by canceling out the 2's and the 3's. So it becomes this. And then we use this. So it says y of 1 is 4. So y of 1, so we use x as 1. So we'll end up with 4 is equal to 5 plus c. C is equal to -1. And some people forgot to write the final equation, which I mentioned in the review. So we plug in c equal to -1. So that was your final answer. Okay, we had two other types of u substitutions, which guys didn't seem to, most of you didn't quite get it right, so be prepared. So what we've said is the argument of the square root is u, not this part is not u, because then you'll end up with the square root of something that's not u, so it doesn't really help you out doing the other way. If you said u is x minus 1, it's not really going to help you any. So u is x plus 2. I need a substitution for x, so all you do is solve for x. So if you subtract 2 from both sides, you'll get that. And then if you take the derivative of either one, you get du is equal to dx, or dx equals du. The only time you wouldn't get that is if this was like 2x plus 2. Then it would be du would be 2dx. But okay, so we can make the substitutions. For x, we put in u minus 2, and then we subtract another 1, because x is u minus 2. The square root becomes the square root of u, and dx becomes du. So we do the math. Some people didn't do the math. Go ahead and figure out what that is, which is u minus 3 times the square root of u. Now u, square root of u is u to the 1/2 power. So now you plug that in. Well, now you multiply it out, so you get u to the 1st power plus times u to the 1/2 power, which is u to the 3/2 power. And the second part is u to the 1/2 power. Again, we put parentheses around this whole thing times du. If you don't have the parentheses, then it doesn't make sense mathematically. Okay, so now we've done the substitution. So it's a polynomial, which we know how to handle. So you add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent, add your arbitrary constant c, and then we'll take the reciprocal. So instead of dividing by 5/2, we're going to multiply by 2/5. Here the 3's cancel out, so you just end up with a 2. 2/3 times 3 is 2. And you get u to the 3/2 power plus c, and then finally you plug in what u is equal to, what you chose it to be here initially, which it's x plus 2. And that's your final answer. Okay, so that's the first half of the test. Now the next one says simplify into 2 terms before integrating. That means it's not a suggestion. That's I won't say it's not an order, but so we talked about this in class. So we just divide each one of these terms in the numerator by the square root of x. So this is to the 1st power. So 1 minus 1/2 is to the 1/2 power. Some people got to the -1/2 power, but 1 minus 1/2 is 1/2. And here we have 3 minus 1/2. So 3 is 6/2. 6/2 minus 1/2 is 5/2. So that's what I'm asking you for. Simplify into 2 terms before integrating. Okay, now you can integrate it, so they don't have to use u substitution. They're just polynomials. So you add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. Add your arbitrary constant c. At that point, we've done the integration. Remove this, add the arbitrary constant c. Okay, take the reciprocal, so you'll have 8/3 x to the 3/2 power minus 2/7 x to the 7/2 power plus c. So that's your answer. Okay, number 8. So here we have the integral of 4x squared secant squared of 2x cubed dx. Okay, so obviously we don't have anything for that, so we got to use u substitution. The argument of the trig function is u. So when you take the derivative, the differential du, it's going to be equal to 6x squared dx. You can see if I factor out the 4, I'm going to have x squared dx. So if I solve for that, I'll get du over 6. Okay, so now we can do the substitution. Bring the 4 out. This becomes secant squared of u, and x squared dx becomes du divided by 6. I guess this case I don't need the parentheses. If I put it in there, that's fine, but I don't need it because it's a multiplication, so that's not in question. So factor out this 1/6, the integral of the secant squared of u du. That's something we know. It's a tangent, and we can simplify 4/6 down to 2/3. So we get 2/3 2/3 tangent of u. Now we add arbitrary constant, get rid of that, and then we plug u back in. So we get 2/3 tangent of 2x cubed plus c. And again, notice because I have something here other than u, I have to put parentheses around it. If I just did 2/3 tangent of 2x cubed, I might think it's the tangent of the number 2 times x cubed, not the tangent of the quantity. So that's why those parentheses are needed. Okay. Number 9. So now we're into definite integrals. So again, we have the square root term, so most likely going to be u substitution. So we'll let the argument of the square root be u. So when we take the derivative, you'll get du is equal to 8x dx. Now, because we're doing a definite integral, we're not going to substitute back in. We're going to change the limits. So when x equals the lower limit, u equals 4 times 1 squared plus 3, which is 7. And the upper limit for u equals 4 times 4 squared plus 3, which is 67. Also, x dx, here's x, here's dx, is equal to du divided by 8. So we can rewrite the original integral. In this case, we're also going to change the limits of integration. And we're going to put in du divided by 8 at this point. So we factor the 8th out. We change u square root of u to u to the 1/2 power. Like that. And then we just do the polynomial integration. So we add 1 to the exponent, divide by the new exponent, put this vertical line to show us that we are going to evaluate this function at the upper and lower limit. Now if I take 1/8, if I simplify this, you take the reciprocal of 3/2, which is 2/3. So you get 2 over 8 times 3. That's 2 over 24. So that simplifies down to a 12th. And then you take 67 to the 3/2 power minus 7 to the 3/2 power. And get your calculator out. I think the average is somewhere around, I think the number's around 40 something. So 1 divided by 12 times 67 to the 3/2 power minus 7 to the 3/2 power. And you get 44.2. Okay, so that's the answer for that one. Okay, the next one is we have the integral from pi over 7 to pi over 5 of the cosine cubed of x times the sine of x dx. So what we have to do is remember that the cosine cubed is the same as the cube of the cosine. So this becomes the cosine of x cubed sine of x dx. So at that point you say, oh, well, I guess that makes it cosine of x, probably a good choice for u. And du is going to be negative the sine of x dx. So the derivative of the cosine is negative the sine. You see I have the sine of x dx, so you get that. Now, because again it's a definite integral, not only are we going to change the variables, but we're going to change the limits. So when x equals pi over 7, u equals the cosine of pi over 7. And that is something, I'll get my calculator here, and you got pi over 5. U is equal to the cosine of pi over 5. So you've got to make sure your calculator's in radians. So you've got the cosine of pi divided by 7, which is 0.900, or actually 0.90. And you don't have to carry it this many decimal points out, 0.901. And you do the same thing for pi over 5, and you get 0.809. So this integral becomes the integral, instead of from pi over 7, from 0.09 to 0.809. This is u cubed. The sine of x dx is negative du. So factor out the negative sign. The integral of u cubed is u to the 4th over 4. We draw this vertical line to tell us that we need to evaluate the integral between these limits, like that. So you get negative 0.809 to the 4th over 4 minus a negative 0.901 to the 4th power divided by 4. So this is evaluating this function at the upper limit, subtracting the function evaluated at the lower limit. So you get 0.809 to the 4th power divided by 4. So that's negative 0.107. And we got the minus times a minus, so that's a plus. You get 0.901 to the 4th power divided by 4 is 0.165. So you take that and subtract 0.107 and you get 0.058. Okay, next one. Again, the next one is one of those where you don't have to use u substitution because it's just a polynomial. So we just do the polynomial integration. So each one is a polynomial. The integral of the sum and difference is the sum of the indifferences of the individual ones. So you get 3. The integral of x cubed is x to the 4th over 4. Then you've got 3. The integral of x is x squared over 2. The integral of 4 is 4x, and you draw this vertical line to show that you want to evaluate this whole thing between 2 and 4. So we've got 3/4 times 4 to the 4th minus 3/2 times 4 squared plus 4 times 4. So that's the function evaluated at the upper limit, and then you subtract the function evaluated at the lower limit. So we got 3 times 2 to the 4th minus 3/4. So 3/4, 2 to the 4th minus 3/2, 2 squared plus 4 times 2, close parentheses. We see one of these cancels out with those. So you got 4 cubed, which is 64. 64 times 3, I think is 192. So you get 192 for this first one. Here we have 16 divided by 2 is 8. 8 times 3 is 24, so you get negative 24. 4 times 4 is 16. So those are the upper limit values. Then you've got the next one. So we've got 2 to the 4th power, which is 16. 16 divided by 4 is 4, so you get 3 times 4, which is 12. Here we get 2 squared, which is 4. 4 divided by 2 is 2. 2 times 3 is 6. And 4 times 2 is 8. So you've got 192 minus 94. 192. These two, you get negative 8, right? 24. 16 minus 24 is negative 8. And then subtract 8 from 192 would be 184. And here we subtract, we've got 8 plus 12 is 20, minus 6 is 14. So you get 184 minus 14, which is 170, which is the answer. Okay, and then the final one is another one of these second types of U substitutions. So we go integrate from 1 to 3 of 2x minus 1 cube root of x plus 3 times dx. So again, for the second type of U substitutions, U is what's in the square root. But we also need this substitution for x, so we take this and solve for x, so it's u minus 3. Dx equals du, or du equals dx, because I've just got x by itself here, or u by itself. So, and then we have to change the limits. So when x equals 1, u equals x plus 3, or 1 plus 3, which is 4. And the upper limit, when x equals 3, u equals 3 plus 3, which is 6. So with those substitutions, we're going to integrate from 4 to 6 of 2 times x. X is u minus 3. Then subtract 1. And then take the cube root of u, du. So x is u minus 3. Here we have the negative 1. Cube root becomes cube root of u. So we can do two things in the next step. We can simplify this. So we'll get 2u. 2 times u is 2u. You'll get 2 times negative 3 is negative 6. Minus another one is negative 7. So that part becomes that. You rewrite the cube root as u to the 1/3 power. Okay. Before we integrate, we multiply all this stuff out, so you get 2u. So this is the first power. 3/3 plus 1/3 is 4/3. The second part is just u to the 1/3 power, 7u to the 1/3 power. Put parentheses around here. Everything times du. And now we just have polynomials. So we take the polynomials, add 1. So 1 is 3/3. 4/3 plus 3/3 is 7/3. That's my new exponent, so I divide by that. Then I have 7, add 3/3 to 1/3, I get 4/3. Divide by 4/3, and then I'm going to evaluate that between 4 and 6. So what we're going to have here is take the reciprocal, you'll get 3 over 14, so 3/14. Nope, 6/14. 3 times 2 is 6. U to the 7/3, and then do the same thing here. You'll have 7 times 3 is 21, so it's 21/4. U to the 4/3. Whole thing evaluated between 4 and 6. This is 2/7. Simplify. No, it's 3/7. Just double checking here. Okay. So we'll have 3/7 times 6 to the 7/3 minus 21/4, 6 to the 4/3. So that's the integral evaluated at the upper limit. And then we have 3/7 times 4 to the 7/3 minus 21/4 to the times 4 to the 4/3. So that's evaluated at the lower limit. And I said to do it as decimals, so we can just plug this in our calculator. 3/7 times 6 raised to the 7/3 power minus 21 divided by 4 times 6 to the 4/3 power minus 3/7 times 4 to the 7/3 power. It's a minus times a minus, so I get plus 21/4 times 4 to the 4/3 power. And something's wrong here. Oh, I see it. Missed a parenthesis. Okay, just double check my results here. Yeah, I've done something wrong. Let me go back. I'll go back and let you know. I'll be back in a millisecond. Okay, yeah. Something was a little fishy there. Okay, so let's do this. So when you do this, you get 6/7. Okay, so now I'm plugging back, just going back to my equation here and replacing 3/7 with 6/7. And the answer should be 10.4. There we go. So if you plug those in, so let me just do that. So you have 6/7 times 6 to the 7/3 power minus 21/4 times 6 to the 4/3 power. So that's the function evaluated at the upper limit. And then you subtract the function evaluated at the lower limit. And if you do that, you get 10.4. And that's your final answer. So there you go. So the final exam, so we're not going to have a test number 5. The final exam will be everything that we've covered this semester. Probably about a third of it will be chapter 5, and 2/3 will be the other chapters, and everything that was covered on the first 3 first 4 tests is game, so I'm not going to do any special review, except I'm going to do a review of Chapter 5. So the exam review is all the other reviews. And again, you should probably go back and look at this again if you didn't understand it. You have the link so you can watch it at home. And that's one thing, I'm sure this course is different than if Ms. Pratt was doing it, because this is kind of a semi-online class. But it's the reality of the situation in college. They're going to spit out a lot of information at you. You're going to be expected to be responsible for figuring out what the answer is. And you're not going to have as much guidance as you have in a high school class. And so you need to be able to get used to working independently, or you're going to have a poor experience in college, especially if you're going to major in math or science or engineering. So hopefully you'll use this as a learning experience and improve your ability to work on your own and use the book, read the book, look at the examples in the book. So that's my little pet talk.